You're listening to China Manufacturing Decoded from the Sofeast Group. Hi, it's episode 230 of China Manufacturing Decoded, the show from Sofeast. Adrian here on hosting duty this week, and Paul Adams joins me. Hello, Paul.
Hello, Adrian. Good to be back, sir. How are you doing?
Yeah, well, thanks. It's the British takeover again.
Come on, let's go. Yep. And I can't believe 230. Can you believe it? 230 episodes. Nice one. Congratulations, everybody.
Yeah, well, congrats to the listeners, everybody that keeps showing up every month. And it's great that people are really enjoying it. And that does kind of bring me on, before we go into this week's topic, if you are listening and you're wondering, hey, these guys are not covering the topic that I want them to talk about, well, we are totally open to that. So you can get in touch with us. If you go to sofeast.com, so that's sofeast.com, and go to the contact form, and you can fill it out and leave us a message and just say, "Oi, please cover this topic in your podcast. We'd love to get more info on that." Then, yeah, we'll totally give it a whirl, won't we, Paul?
Absolutely. Just let us know, and we'll more than oblige.
Yeah, so, I mean, between yourself, Renaud, everyone else in the team who appears on the podcast, we've got so much experience and competence in a lot of important topics. We can totally get these topics covered. Right, let's crack on with today's topic. Paul, we're talking about silicon compression molding, and what we're hopefully going to do is understand what this production process is and how it can be used in, well, developing new products, but also mass production. And of course, these are silicon products. So why is this important? Why should people know? Why should this be on people's radar?
Well, when we're talking about molding, yes, automatically, you think about injection molding, plastic injection molding, but it goes a little bit further than that. And this is where we bring in the silicone stuff. And particularly what we're going to be focusing on today is the silicone compression molding process. Now, there is another one called sort of liquid silicon rubber injection molding, and that is injection. And we'll cover that later on. But I really want to focus on the compression molding process, what it's used for, when the products can be used, why it's important, and some of the common products that are used in this process. And this is a really important process because it allows for very low volume during your product development, as you mentioned earlier, as well as moving into more of a mass production without worrying about, so can I produce millions of these products, or, what is it really suited for? Well, the answer is this is really, really flexible with respect to quantities delivered from the process itself. So that this is why it really does fit nicely into the product development and mass production bracket, let's say.
Yeah, which arguably you might not say for processes like injection molding, plastic injection molding, for example, using the hard steel molds, where you're probably going to be expecting to be making really huge numbers, and arguably in some cases that's probably not so good for development. So, but we'll get into that, won't we?
Indeed, yeah, okay. And absolutely, we'll look at the molds, we'll look at the process itself, we'll look at some of the silicone that we should be using and why we use it.
Yeah, and you mentioned sort of everyday products, and when we think about molding and molded products, plastics do spring to mind, and of course there's a huge number of plastic injection molded parts and enclosures products out there, and those are definitely everyday. However, silicon products and parts made using compression molding, they're pretty common as well. So it is going to be interesting to hear about the sorts of products that we do make. So let's go into what this process is then. So what is silicon compression molding?
Good. We're going to touch on some of the other aspects that you mentioned, but what is silicon compression molding? Well, it's compression. So let's look at that first. So for the compression aspect, you need a top and a bottom, or a male and a female, core cavity tool. Very similar to injection molding from that aspect, but on a simpler aspect. We're talking about a two-drawer, in other words, open and shut tooling process where you've got your piece of silicon, which I'll talk about in a minute. You put that into it's a pre-cut form silicon that goes into the cavity. The machine then closes the two halves of the mold. The mold is heated. Okay, so this is an important aspect. It's then put into the press, and the press then shuts it under force, which is your compression part. Okay. And during that compression, your pre-cut form silicone, whether that be in a circle, round, dog bone shape, whatever the case may be, then is compressed into the final form of the core and cavity, taking on its final shape. Okay. The machine is then held under compression. And while the tool is hot, I've already mentioned that, and this heat cures the silicone. Okay, so we need that. There's a lot of refinements with respect to the pressure the tool is held together, the temperature that the tool is heated up to make sure that the silicone is being cured, and the time the silicone is being cured for. Okay, all of these processes, all of these parameters need to be carefully fine-tuned by the expert running the machine. But basically, during that time, the slug of silicone, or the blank of silicone, is then transformed into the final shape and cured. Once the time is up, it's the preset time for this particular component. Each component would have its own curing time. The tool opens, okay, and then you can remove the final product. Okay. Now, the final product will have flash and excess material around the edge where it's squeezed together. Let's try and think of an example where you've got. Well, we come from sort of the UK, and when we're down the seaside, Adrian, we'll go and get one of these ice creams into wafers. If you squeeze those two outer wafers, this is like a tool, okay? And your soft ice cream in the middle is like your silicone. And if you squeeze it too much, you're going to get excess ice cream squirting out. Exactly the same thing happens here. So we don't worry about that because this is all trimmed off and cut later on. Okay, but you would definitely have that flash on there. So the process is you put your slug or your blank of silicone in, and you could have multiple cavities of this, okay, of the shape. The mold is then closed. It's then compressed under pressure while the tool is heated. That cures, and then you remove it. That's the whole process of how we get going from a blank material to a finished, well, I want to call it a semi-finished product, because in this process there is post-molding, let's say, process required to remove the flash and everything.
So it's kind of it's similar to injection molding in a way, but instead of injecting the silicon, we sort of squash it into place.
Correct. That's exactly it. That's exactly
to fill the mold.
Yep.
Okay. Yeah, I get it.
Yeah. And another sort of differentiator here is you got your injection molding machine, and you can see these running, and they're on a horizontal plane. In other words, like the tool opens horizontally, whereas 9 times out of 10 on compression molding, it's on a vertical plane. So your pressure is coming from the top or the bottom, depending on what machine you've got. So it opens up on a vertical plane.
Okay. Yeah, so that's clear. And actually, we've got one of these silicon compression molding machines in Agilion. So we are now using this. We're now using this for producing silicon parts and products, and also in the development process, depending on exactly what the application is for our customers, right? So that's actually on the Agilion website, and we've even got some video and stuff. So look out for that. I'll leave some links in the show notes so you can sort of visualize how this thing's working that Paul's talking about. If we compare compression molding of silicon then with some of the other molding techniques? Like you've mentioned plastic injection molding, which is the obvious one, right?
Yep.
But are there any other techniques that are worth comparing it to as well?
Well, you got transfer molding,
Mhm.
which is something very sort of similar, where it uses heat and pressure and forces the preheated material into a mold. Very similar process. But, the injection molding is using a dried polymer, which is in a pellet format, which is then processed through screw format, which polymerizes the pellets. And then because that's heated as well, that turns it into a molten material and then injected into heated cavities. So that's how that works. And what I mentioned earlier, liquid silicon molding or liquid silicon rubber is injection molded in a similar fashion. And we are planning to actually bring that into a sort of Gillian plastic molds at some point in the future.
Yes.
So once we've got that, then we'll sort of cover that in more depth. But because we've got the compression molding, let's focus on that for the moment because we've got it and we can offer that service. So, we've got the typical liquid injection into a machine versus putting a slug of material and compressing that into shape. That's the two differentiators between the processes, really, which is a key thing. And one of the main advantages of the compression molding for silicone is the simplicity or lack of complex tooling, okay, compared to injection molding, right? You don't have all of the sliders and all of the complex aspects that go into making an injection mold tool. For the compression molding, the tooling is less complex for sure, and therefore making it more cost effective. And it's a different material, so it needs to have a different process anyway. But I want to come back to what we first talked about. This process is great for low production volumes and product development, but it's also perfect for mass production because this is something that can be scaled with respect to, depending on the size of the actual product that's being produced. You can have multiple cavities in a tool. And in fact, the machine that we have in Gillian Plastic Mold is a side-by-side two compression machine. So you can have one side actually producing and compressing the two molds while the other side is being loaded, ready for the next batch to be produced. So, it's quite effective from that point of view, but it's very cost effective as well.
Yeah. So I think we're starting to touch on the benefits of this particular process, right? And we can see how it's different to some of the other molding techniques, right? But if we look at the benefits, I suppose we're talking more about silicon's benefits and why people choose silicon to make their particular part or product. In some cases, the only choice is silicon as a material.
It's right. It's not really looking at the benefits of the process itself because the process is really defined and determined by the actual product you're producing. If you're producing high volume components that need to be rigid for an automotive product, then clearly, you're not going to produce that out of silicon.
No.
But if you're looking for, various different products that need to be used in medical devices or in kitchen aidware or some of the general household products around you. I can't believe when I had a look around my house at how many silicon products are actually in use on a day-to-day basis. So, which is really good. So this is where we're really talking about the benefits. Now, when it comes to benefits from silicone, you can see that, a lot of this product is used in high temperature environments, also low temperature environments. So silicon is a very, very stable material at elevated, both top and bottom temperature wise, is very resistant. So I've got a lot of silicon ice cube trays in my freezer. My wife also uses it for baking. She's been doing this a project for my little girl at school today, baking muffins, using silicone again.
Oh, nice.
And this is very, very resilient when it comes to sort of temperature. It's also excellent when it comes to electrical insulation, so which is another great sort of product application for this material. So, which is really good. Non-toxicity and hypoallergenic comes to mind. And when it comes to medical, you can also get food grade sort of silicone. So this is great for anything that is used for sort of food grade, which I've already mentioned used today, just in my house, everybody else's. So, the challenge there is to look at the actual properties and what the product's going to be used for, and making sure that we're actually choosing the correct base silicone that meets that requirement. Okay, whether that be high temperature, low temperature, FDA approved for medical devices and products. Silicone, it has so many benefits. It's incredible. It's a brilliant material, but it has to be used in the correct application. You know what I mean?
Yeah, if we dig into the properties a bit, because it's such a versatile material and it has so many beneficial properties, and this is why people choose it. So you mentioned the temperature sort of resistance, and we're talking about cold and hot. I believe
yes, right.
I believe it operates well from minus 55 degrees C to 300 degrees C. So for North American listeners, that's minus 67 Fahrenheit to 572 Fahrenheit without degrading. So, I mean, doesn't matter whether you're in Arizona or Alaska, that silicon's going to be okay. So, I mean, no wonder they use it in auto components, for example, so much, right?
Exactly. Yeah.
And chemically stable, so it's chemically inert, so it doesn't really react with other chemicals. So acids and things like that can go on silicon and it won't affect it. So again, it makes it's understandable why you would choose this for, lab equipment or your food grade products and things like that. When we think about silicon, it's probably people think it's pretty stretchy, right? So it's flexible, it's elastic, it can take some stress, it can be bent and pulled. And again, if we look at cars, autos, gasket seals, O-rings, things like that, there's tons of these in your car. You might not see them, but they're in there, right? So there's lots of silicon parts. Yeah, the sort of tubing for the AC system and things like that, these are all going to be silicon because they are quite flexible. So that's good. I could go on. Water and moisture resistant, so outdoor uses. An electrical insulator. If you've had any wiring done in your home, probably a lot of the wires are going to be silicon coated, right?
Indeed, the material itself is so versatile.
So yeah,
so versatile, it's brilliant.
So inside, outside, inside car engines, used for outdoor signage, things like that, sealants, all of this sort of stuff. It's pretty wonderful material. So that gives you some insight into why people would choose this. If we keep on going with benefits, cost effectiveness. I think you mentioned before about kind of the cost implications of injection molding, because we're talking about large scale production here, probably quite high MOQs from your supplier in many cases. Is silicon compression molding more cost effective?
I think it is. If you look at the cost, all right. So say if you got a like for like design and a product, and one of those products is a silicon base. Okay, so we're using the compression molding silicon process for that, and the tooling is a similar cost, let's say, to an injection molding part of the similar type. But we're going to be using a soft polymer. Because we're going to be doing comparison of the two. Or it's the actual process of the injection molding is more harsh, let's say, than it is on the compression molding for the silicone, because the silicone product itself is not harsh, it's not affecting the actual tool itself, and long term you will find that your compression molding is more cost effective than a lot of the other processes out there. Okay, if you do that comparison,
interesting.
it is.
And on the same tack, right? You mentioned that there'll be some flash that sort of squeezes out and needs to be trimmed away. So that's going to be in, when the parts are being finished after they're coming out of the press, presumably. With the excess silicone, can this then be reused?
The flash can often be recycled. The similar thing to what we're using when we're talking about injection molding, where we've got the trim or we've got the sort of the waste material. That is also recycled, but we also have a percentage that we put in now because the silicone's been through a curing process. It's no longer that base silicone that goes in as a virgin material, let's say.
Right.
So again, we're looking at careful regrinds and reuse percentages into the new material that goes in, let's say. But you got to be very careful when it comes to what the product's going to be used for. Now, if you're looking at medical products, I would not recommend putting any recycled flash into the raw material, because that needs to be very highly controlled as a material, particularly if it's going inside the body, for example, or anything like this. Yeah. Whereas, if you're using it in an automotive non-critical component, then sure. Yeah, let's have a look at it. But again, it's really looking at the percentage that goes back into that, and it needs to be very carefully monitored.
Okay. That's the same with a plastic injection molding. Correct. As well. And I suppose your experienced mold technician or engineer they're going to know the balance to strike. So, but
that's right.
If you are able to recycle some of it, then that goes towards your cost effectiveness and sustainability as well. Less waste.
Absolutely.
So
absolutely.
So it is possible in some cases. And when we think about injection molding, how complex parts can be created these days out of plastic, right? I mean, extremely intricate. And so does compression molding for silicon also allow complex geometries and designs?
Less so, to be fair, less so. It's, we can with injection molding, you can get very clever with sliders and lifters and expandable cores, and do all sorts of really, really clever things. In mold cutting processes, which we've got down to a fine art internally now. All of this can be achieved from a relatively a complex mold, and the complex mold is very expensive. Let's face it, to produce this. I would like to think that silicon rubber molding on the compression side is a simpler process. In other words, yes, you can have some complexity in there, but in general, what we like to do is keep it as simple as possible. Okay, so this is basically where we're coming from. From a design point of view, you've got that flexibility in some cases, but let's keep it as simple as possible, where we've got that simple up and down process of the tools opening and closing. That would be my recommendation on this.
Right. Okay. So when we're considering this particular process, then it's horses for courses, as we say in the UK. I don't know if yes. American listeners, for example, you're thinking, what is he on about this time? But you're going to select it when it's appropriate for your needs. And we've kind of touched on some of the products before, the parts that can be made from it, talking about, tubing, O-rings, gaskets of certain descriptions, the head of a spatula for your kitchen. An ice cube tray, mobile phone case. All of these are relatively simple products, to be fair. They're not necessarily extremely complicated.
No, but some of the components can go into a complex assembly. It's like often used in aerospace, for example, which is on a critical component going into sort of very complex assembly. whether that be an aircraft, a spaceship, or whatever the case may be. So, a relatively simple process, let's say, can be used and utilized for a very complex final product and a very important one. So, again, we touched on some of the common applications that you used silicon for.
Yes.
And, it's people often think about household goods. But it goes way past that. Way past that. And one of the biggest things is the medical industry. Because silicone is such a good material to be used in that particular industry. As biocompatibility. You talked about heat resistance, therefore it can be sterilized very easily because it can withstand high temperatures. So that's really important. It can be used in medical implants and prosthetics. Really super, super important when it comes to comfort. It's if you're using silicon sleeve over a stump where you've had your amputation, for example, it needs to be really, really comfortable. And silicone is the perfect material for that. And a lot of people, don't think about that. And also that can also be used in consumer electronics as well. You mentioned phone case, but inside consumer electronics itself, talked about seals, you talked about O-rings. All of these things, you take for granted, as a very, very important material that can be used in so many different applications. This is really a key material in daily life.
Yeah. So I know medical devices are a specific niche, so not everybody's going to be making medical devices, and of course they're quite highly regulated. But I can understand why silicon compression molding is actually quite an important process for this industry then, because if we look at all the benefits of silicon, then naturally, it really does lend itself to those medical devices. And I mean, if we think about implants, you've mentioned for a moment, right? Would there even be an alternative to silicon? Can they literally use any other material? Probably not.
Probably not. Yeah. Maybe in the future. Who knows? Silicon is so versatile. It can be used in such, in applications which are critical to life saving, as well as making ice cubes in your freezer. It's so diverse. It's incredible. It really is.
Yeah, absolutely. Okay, good. So we're getting a real firm grasp of how useful silicon as a material is, but also the compression molding process. Now, if we move on to the next part, then talking about challenges and considerations. So, if we're looking at challenges, what sort of challenges might companies face when they're actually using silicon compression molding? And when we talk about the considerations as well, I'd also like to go into, what are we going to be thinking about when we're using this for development as well as production? So I'd like to strike the comparison between those two different activities. But if we start with some challenges first, Paul.
Well, yeah, you're right, because we've been bigging up this process and patting it on the back and making it, sound really, really good. But clearly there are limitations and challenges when it comes to silicon compression molding as a process itself. And one of those is the design complexity itself. That can be relatively significant, specifically when it comes to intricate parts. We talked about medical parts, and some of those can be very fine details required. That's a challenge. That's a challenge when it comes to compression molding versus injection molding, which you talked about is a little bit more easier to get all of these like fancy lifters and sliders and stuff in there. So that's a challenge. So if your design has relatively complex geometry, you could well be struggling when it comes to tool design. You need someone on board that knows exactly what they're doing from this point of view. Draft angles as well. We talked about the simple process of open and shut and everything like this. Well, it's because this is a rubber, it does tend to stick when you sort of separate the tools out. That can be an issue in some cases. So we need to look at draft angles. They need to be greater in general than what we do with injection molding. However, if you want a parallel draw, in other words, 0 draft angles, can be done, but it is more of a challenge. We're talking about challenges. This is another one that we need to look at with respect to how do you get those components that are in final form out of the tool itself. Now, in general, you can either have 2 ways to do this. Have ejector pins pushing out, and not necessarily pins, but, posts that push this out, or a lot of the time it's blown out with compressed air by the operator. And talking about operator, the operator is more hands-on when it comes to this process as opposed to injection molding. Okay, so consequently, the cycle time goes up. So if you're looking for a rapid, high quantity turnaround in mass production, you need to take into consideration the cycle time is going to be longer with this process than it is with most other molding processes because of that hands-on time. And in general, the cycle time is longer because of the sort of curing cycle and stuff like this. So from that point of view, yeah, there are challenges. But, if you've got an experienced mold maker, if you've got an experienced silicon expert on the team, all of these add up and help mitigate some of these challenges or overcome some of the challenges that, in general, silicon compression molding face. And we're lucky enough to have sort of people like that on our team, which is great.
Yeah.
And that's that. But
it's the same with anything, isn't it? You got to get that advice where you need it.
Exactly.
Don't go crashing ahead and then find out, I've missed something important.
Yep, indeed. And I want to touch on what you asked about earlier that you'd like to discuss was how do we go about this when it comes to sort of product development? Well, the key thing is like communication. Okay, if this is your first rodeo with respect to producing a silicon component, reach out to somebody that knows what they're doing. Okay, so that's the first thing. Okay, that's super important, as you mentioned earlier, Adrian. But it's really a case of if you don't understand this, you really should get some education on the process itself, which we're trying to do here a little bit for your listeners, and trying to understand those limitations, those considerations that you need to put into place when you're designing a product that needs to be produced in silicone. Now, we've already talked on this is a perfect process for low volumes, but it can be scaled. Okay, clearly this process can be scaled, at the right levels of volume. You just need to take into consideration the quantity of cavities in the tool, how many machines you've got, etc., etc. But it's perfect for product development. When it comes to low volume, I wouldn't say it's perfect for fast iterative changes in development. Now, from that aspect, you really should be looking at an alternative process. But once you've got design pretty much refined and nailed down, then you can actually start to go into pre-production without too many issues on a quantity point of view. But if you're going to be going, and this is exactly the same case when it comes to injection molding, if you think you're going to be developing a product from steel tooling, that's the wrong decision, because you're investing in tooling without actually finalizing the design. Okay, this is a big mistake, regardless of what process it is. Okay, so you really need to be looking at product development. You really should be looking at alternative prototype processes, which we'll cover in an alternative podcast. I know we've already sort of discussed that in depth in other series. But, we really need to pin down your design before you start cutting steel. But once you've cut steel, compression molding here is perfect for that slow start, that slow ramp up. Not a problem. So
Great.
it's really good.
Great. Yeah. I just thought development needed a bit of a name check as well. So good stuff.
Yeah.
Okay.
It does.
Right. And let's finish off then with some questions, and there are some frequently asked questions to cover. So, relatively quick fire. How long does it take to develop and produce a part using this process?
How long's a piece of string?
Yeah, I know. That's a good one, isn't it?
Well, to be fair, yeah, it depends on the size and the complexity of the product itself. However, there are general rule of thumbs. It's for a steel tool to be produced, you're talking 4 to 6 weeks. Something like that.
Okay.
In general. And again, we go through the same process when your standard injection mold will go through. You got your T0, which is like, okay, you got your tool basically shaped out. Let's make sure everything's working okay. We've got some product coming out, but it's not refined. There's not refined. You may need some modifications to make sure your tolerance is okay. Make sure your texture's okay. Make sure your logo's in there. That's where your T1 and your T2. T1, T2 is like trial 1, trial 2 before the products get signed off. Okay. So in general, you're talking 4 to 6 weeks.
Okay. What are the typical tolerances and QC measures?
I would say in general, we can actually look at around, I'm going to focus on the American side here, the old speak. We're talking around, plus or minus 10 thousandths of an inch. That's basically where we're looking for on a silicon compression molding. Injection molding, you can get better than that. But I think from the silicon part, this is pretty good. Bearing in mind, this is flexible and, compliant. So therefore, if you're talking about a part fitting into another part, it does have that sort of flexibility. But in general, you're talking about 10,000.
Okay, good. And tips then. So as one of our most experienced engineers, what sort of tips do you have for our listeners about how to get the most out of silicon compression molding if they choose to go down that route?
Optimization. You really need to look at optimizing your design for the component, making sure that you understand where the component is being used and making sure you're selecting the right silicone to apply into that particular part. Now, when I'm talking about selecting the right silicone, this could be another whole 40 minutes we can talk on. But, you've got to take into consideration each range or type of silicone has its temperature, up and down. It has its own hardness, or in this case, durometer. Okay. And each of these things needs to match the applicant or application. Okay. So that's one thing there. Another tip is making sure you're going in with the right partner. Don't go in with some of the Backstreet Boys that say, yeah, we can deliver anything you want, sir, no problems. And you spend 6 months, arguing correct anything out. You really need to make sure you're going with a reputable manufacturer, and you can do this by the simple fact checking. Check the websites, do some background research, do your due diligence, ask the questions, ask some relatively complex questions to see what answers you get back from your manufacturing partner or potential manufacturing partner. That's a good thing. Ask for their track record. Ask them to show some of the products that they've shown in the past, if they're allowed to show them, depending on confidentiality issues and everything like this. So that's another tip. Make sure you're working with the right partner, reputable partner.
Solid.
Which is good. And implement making sure that we've got effective quality controls in place. And again, some of these Backstreet Boys go, yeah, no problems. They're measuring things with a steel rule, which is not particularly brilliant. And then, but you need to make sure that you've got somebody, as in your manufacturing partner, has clear quality controls in place, because this will ensure that you get repeatability and consistency over the batch of products coming out and being delivered. So, which is really good. And we talked about recyclability of, the flash or the scrap or the parts that are no good. Ask what your supplier does with that. Some of these can be recycled. Some of these can be recycled into 100% reusable bicycle seats. The quality of the material coming out of there is perfect. Make sure they're not just bin it. So it's really important from an environmental point of view that your partner, the manufacturing partner, takes that into consideration, which we do, which we clearly do, because we're very conscious of the place we live in called Earth.
Yes, and that they're not putting in too much as into your virgin materials,
That's a key.
to try and cut some corners and make a bit of extra profit, perhaps, which is something to keep an eye on.
Yes, very much so, very much so. Now, one thing that we haven't touched on at all is color. And again, there's another 40 minutes we can discuss on how to color your silicone.
Right.
But a tip here is making sure that you, in general, pass over the correct information of what you want. Now that includes the silicone itself, the properties that are required from the product itself, whether that is going to be food grade, whether that is going to be medical grade, whether that is going to be kitchen grade, whether that is going to be automotive grade, whatever the case may be. You need to make sure you've getting that across, making sure you've got your 3D file correct, making sure that you've got your 2D dimensional accuracy is written down, not too tight, not too loose. You need to make sure you're getting the correct information across to the supplier. Okay. And making sure that your color is Pantone referenced or RAL referenced or some other reference to work against, instead of, I'd like it a blue color, sky blue. Yeah. What color? Well, look at the sky. Yes, I want it that blue.
Good luck with that.
It's too vague. You need to make sure. What I'm saying is, your takeaway tip is, get the correct information to your supplier. Otherwise, your supplier will be guessing, and they will guess wrong.
Yep.
Okay.
Yeah.
So I think,
the color's a good one, actually. Yeah, I suppose that's one of the benefits as well. Silicon is quite customizable when it comes to color. And you see, if you think about your ice cube trays or your phone cases, loads of colors, right? But if we look at plastic injection molded plastic parts, I mean, I don't think they're not exclusively kind of grey, are they? They can be different colours, but oftentimes we think about those and they're sort of a grey colour or maybe like a white colour, but that's kind of, it's limited.
Yeah. I know what you mean. But it's the polymers can be coloured clearly, but silicons can be coloured as well. And with the silicone, I'm not going to go into this now because I'll just get carried away. But coloring is an interesting one. Let's touch on that another time.
Okay.
I think my final takeaway here on this process is, don't ignore it. It's a really versatile process in order to get your silicon material into a final shape that can be used in, you name it, type of industry. So versatile. It's very invaluable material to be used, and I'm happy to say that we can now offer this service within Agillion. Silicon molding.
Listeners, think about when you're developing your product, if you've got parts that could be made of silicon, is that going to serve you well? If so, silicon compression molding might be a great process for you, and it may well work out to be more cost effective than if you went down the route of plastic injection molding instead, for example. So it's definitely something to think about and to ask questions of your supplier about as well, and get their advice on it. It could be a good one. So that's kind of an introduction to the process itself. We've spoken about the many benefits of silicon. We've talked about some of the challenges and considerations that you need to make, and you've gone through some of the questions and really good tips at the end there, Paul. So I think well equipped now to really consider silicon compression molding, which is what this was all about. So that's great. If you're listening and you want more information, you can get in touch on our website or anywhere that you're listening to this. There's going to be links for you to contact us. And once again, please do feel free to submit any questions or topics you'd want to hear more about in future episodes. We're totally up for recording those, aren't we, Paul?
Absolutely. Just let us know.
Yeah.
We've got the skills in-house.
We sure do. So, that's it for silicon compression molding this week. We will be back next week as normal, and Paul will get you back on soon too.
Absolutely. Love to. All right, talk soon.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.